Hello everyone, I'd like to welcome you to this video titled Ratios, and in this video we are going to look at how you use ratios to compare two quantities. And you'll need to get out your Go Math book and turn to page 149 and get out your math journal and a pencil. And the first thing we're going to take a look at here is on page 149 and looking at what ratios actually are. And I know ratios is something that you've talked about before in previous grades, but we're going to quickly go over it here. It says a ratio is a comparison of two quantities. Okay, when we talk about quantities, that's items, number of items of something. Okay, two quantities, it shows how many times as great one quantity is than the other. Okay, so when we're taking a look at it at the stars and the moon, the ratio of star-shaped beads to moon-shaped beads in a bracelet here is 3:1. Okay, and it's important whenever you're writing ratios that you write them in order. So star-shaped beads started first, so that's going to be 3. Moon-shaped beads is the next one, so has to be 3:1. It cannot be 1:3. That would be moon-shaped to star-shaped then. Okay, so now what we're doing is we're looking at writing the ratio of moon beads to star beads. Okay, so I kind of talked about that already. That is 1, 2, 3. Okay, so 1 to 3 is that ratio. And again, I look at how many moon beads I have. I have one moon bead. So I write 1 here, 3 stars, so 3 for the second one. Now the next one we're taking a look at, write the ratio of moon beads to all the beads. Okay, so for this one, I can see I have 1 moon bead, so that's going to be 1. Now all the beads, I have a total of 1, 2, 3, 4, so that's going to be 4. So the ratio for that would be 1 to 4. So the next one says, if the bracelet has 2 moon beads, how many star beads does it have? Okay, so we can see the ratio of moon to star is 1 to 3. So if we were to double that amount, it would be 2 to 6 would be the ratio. So therefore, if there's 2 moon beads, it would be 6 star beads for letter C. Now, taking a look at the next one, if the bracelet has 9 star beads, okay, so we can see the ratio is 1 to 3 here, okay, for moon beads to star beads. So they're saying if there's 9 of these total, all right, how many moon beads does it have? All right, so let's take a look at this. So I'll just write this out. Let's say we have 9 star beads here, and then we have our moon. I know, not the greatest looking moon here. You can just write it out just like that. So total of 9 star beads. Now, how many moon beads does it have? We can see it's a total of 3 beads. And then figuring out how do we know that? There's 1 moon bead for every 3 star beads. So if there's 9 star beads, there would be 3 moon beads. So let's continue on page 150. It's talking about writing ratios now. And the numbers in a ratio are called terms. So a ratio can be written in several different ways. Let's say that we are looking at a scenario where we have 5 dogs and 3 cats, and we're trying to figure out the ratio of dogs to cats. It can be written where it looks just like this, 5 to 3. It can be written 5 and then that colon 3, and then the fraction form 5/3. And it's also important to understand that ratios can compare part to a part to a whole, or the whole to a part. When we're talking about part to part, that would be dogs to cats, for example, or cats to dogs. Part to the whole would be dogs to the total amount of animals. Whole to the part could be the total amount of animals animals to the dogs or to the cats. Okay, so that's what it's talking about, how it can be written a few different ways and also compare different ways, different quantities as well. So let's take a look at the bottom of page 150. We're going to write each ratio 3 different ways. So if we're taking a look at bagel chips to peanuts, that's part to part. So we take a look at bagel chips, which is 3, and the peanuts would be 1, so we could write it as 3 to 1 that way. Also 3 to 1, and then we can write it as 3 over 1. So these are the 3 different ways. Again, this is part to part here. Now, total party mix to pretzels, this is whole to part. Okay, so the total party mix, we can see there are a total of 8 items. So we could write this as 8 total items. To pretzels, there's 3 pretzels. Okay, so 8 to 3. We could do 8 to 3, written this way, and then also 8 over 3. Again, this is whole to part here. Cheese crackers to peanuts. So this is part to part. So we look at cheese crackers, that has to go first. There's 1 cheese crackers and 1 cup of peanuts. So this is 1 to 1. Okay, we can write it 1 to 1 like this. And then also 1 over 1. All the different ways that we can write the ratios here for 5, 6, and 7. All right, now let's look at page 151. And we're going to look at equivalent ratios. And equivalent ratios are ratios that name the same comparison. And you can find equivalent ratios by using a table or by multiplying or dividing both terms of a ratio by the same number. That's the key point. It has to be by the same number. So equivalent ratios have a multiplicative relationship. Okay, so it's multiplying or dividing by the same number. So a ratio with terms that have no common factors is said to be in simplest form. Okay, so for example, 2 to 7 is in simplest form there. Okay, we cannot simplify that anymore. 8 to 24 and 2 to 6 are not in simplest form. Okay, but 1 to 3, for example, would be an example of this ratio in simplest form. We just divide both 2 and the 6 by 2, and that gives us 1 to 3. So let's look at how to create some ratios, equivalent ratios. So we have 8 to 10 is the ratio. And thinking about this as fractions is very helpful. Okay, so what we can do, first of all, whatever you do to one term, you have to do to the other. That's very important. So we can divide both terms by 2, and that's going to give us the ratio of 4 to 5 as an equivalent ratio. So 4 to 5. All right, you can also take 8 to 10, and you can multiply both terms by 2. And that's going to give me 16 to 20. Again, what you do with one term, you have to do to the other. So I'm just going to write this the other way, 16 to 20. And then we can see, make that 6 a little bit clearer there. So 8 to 10, you can you can multiply both numbers, let's say by 10. And that's going to give me 80, the ratio of 80 to 100. So as long as you multiply or divide both terms by the same number, you'll have an equivalent ratio. So as you can see, there are an infinite amount of equivalent ratios to 8 to 10. You could just keep going on and on and on and on forever. Okay, so let's take a look at number 9. All right, so in other words, there's not going to be just 3, for example, that you can write for any of these ratios. So we have the ratio of 5 to 2. Okay, And let's write it out here. So we have 5 to 2. So I can multiply both terms by 2. And that's going to give me the ratio of 10 to 4. Remember, you have to multiply both terms by the same number. Now, we cannot divide 5 to 2 by a number. So this ratio would be in simplest terms. Okay, now we can multiply both terms by 3. Whoops. That's going to give me 15, the ratio of 15 to 6. And then we can also multiply both terms by 4. That would work as well. Multiply 5 by 4 and 2 by 4, and that's going to give me the ratio of 20 to 8. Okay, so again, the key tip for finding an equivalent ratio, you have to multiply both terms by the same number or divide both terms by the same number. So that's how you find equivalent ratios. Now we're going to look at page 153 and number 13 for 153. And it says, in each bouquet of flowers, there are 4 roses and 6 white carnations. Complete the table to find how many roses and carnations there are in 4 bouquet of flowers. So we could see the ratio is 4 to 6. Okay, so that's 1 bouquet here. The next one would be, if I had 2 bouquets, that'd be 8 to 12. Now we have 12 to 18. So you can see what I'm doing for each bouquet. I'm just adding 4 roses and 6 carnations. Okay. Next one, adding 4 more roses to this. 16 roses, 24 carnations. And finally, for my 5th bouquet of flowers, it's going to be 20 roses and 32 carnations. Okay, so again, I'm just adding 4 to each set for roses, 6 to each set for our bouquet of flowers for the carnations. And what we can see here, they're not asking for the 5th one, they're asking for the 4th one, so watch out for that. So we have here total of roses, 16 roses and 24 carnations in 4 bouquet of flowers. So make sure you write that down on page 153. And now the final one we're going to look at is number 14. So it's saying that Ed is using the recipe shown to make fruit salad. We see it right over here. He wants to use 30 diced strawberries in his fruit salad. How many bananas, apples, and pears should Ed use in his fruit salad? Now what we need to do, we need to figure out what the ratio is for strawberries to bananas, strawberries to apples, and strawberries to pears. Okay, so we know he wants to use 30 diced strawberries in his fruit salad. So we have 10 strawberries. So the ratio of strawberries to bananas, for example, is going to be 10 to 4. Now, what do you have to do to get to 30 strawberries? You got to multiply this by 3. Multiply the strawberries by 3. Therefore, we have to multiply the bananas by 3. So that gives us 30 strawberries. And then what we would have 12 bananas. So 12 bananas here. So next one is going to be apples. We have 10 bananas to 3 apples is the ratio. So you have to multiply, again, both terms by 3 because you have to get to 30 strawberries. That's going to give us 30 to 9 apples then. And then pears, the ratio is 10 to 6. Multiply both terms by 3 because we got to get to 30 strawberries there. So that's going to be 30 to 18 is the ratio when there are 30 total strawberries. So again, with this type of problem, what we did is we set up the initial ratio, and then what we did, we found the equivalent ratio by multiplying both terms by the same number. So this concludes the video on ratios. If you have any questions about this concept, please come and see me.